Okay, tomorrow and today and tonight, today and tomorrow, we're going to be data analysis is the process of inspecting, cleaning, transforming, and modeling data. Why are we doing that? Because we want to extract useful information and draw conclusion from the data. Now, there are various techniques that it entails for us to discover patterns and trends from our data. And most of the time, the data is just structureless and is something that has no meaning to anybody. It is the data analysis stages that helps us to bring meaningful inference out of whatever data we are having at hand. Now, there are stages of data analysis. At the very first stage, before you go into data analysis, is that you ask the meaningful questions, ask right questions. Because if we don't ask the right question, there is no how we can actually know the best. In fact, we won't know the right data to collect. And once we are not collecting the right data, everything is already wrong right from the onset. So the very first thing is for us to ask the right question. Okay. Now, questions like, how can we increase the production cost? Okay. Now, how can we retain customers? What is the largest sales we have, and how can we improve the sales in a particular area? We ask questions. Now, it is these questions that is going to drive us to the next stage, which is the stage of data collection. Now, after we have been able to ask the right question about what we want for our potential client or for our clients, that is when we're now going to be able to collect the right data. Now, I said the collection of data is a vital stage in data analysis process. It involves gathering relevant information from various sources to build a data set that aligns with the research objective. Okay? If the research objective is not clearly defined, then the data set you are going to be collecting is not going to be clearly defined. Okay? Now, the purpose and objective of data collection should be clearly defined, and a well-designed study or sampling strategy should be implemented. All right. Now, after we might have asked the right questions about about what we want to do, and we've gotten the questions, we've collected our data. The next thing is the stage of data cleaning. Now, data cleaning is a very important stage in data analysis process, and it's a stage that you cannot just jump it. In fact, 80% of the analysis time is going to be spent on data cleaning. Now, most of the time when we collect data, the data is almost structureless. Data has no meaning. The data is might contain missing values. You might have in fact a lot of things. Now, it is this stage that you deal with those abnormalities. Data cleaning is a critical stage in data analysis process that involves identifying and resolving issues, errors, inconsistencies in the data. Now, it aims to improve data quality and ensures that the data set is accurate, complete, and reliable for the analysis. Now, during data cleaning, researchers carefully examine the data sets. Okay, you check for missing values, you handle outliers, anomalies, and you resolve data entry errors. And of course, some other things like that. It's a very, very important stage that cannot be overlooked. Okay, data cleaning, after we might have asked the right questions, we collect our data. That data that we are collecting needs cleaning. We clean the data. Now, after we might have cleaned the data, we remove missing values, we handle outliers. What are outliers? I don't know. Outliers are, I want to believe people here are not new to the field. I want to believe that. Outliers are, probably you have a classroom of a class of primary 5, and the average age in that class is maybe 10 years old or 11 years old. And you have someone in that class that is 35 years old. That person is an outlier. All those things are supposed to be removed. They are going to be dealt with during the data cleaning processes. Now, After the cleaning of the data, you now move to data analysis stage. That's the main stage. And of course, when we have cleaned our data, this analysis stage becomes very, very easy. It becomes easy, and it can easily bring out the patterns and trends that we want to bring out from data. Okay? Data analysis is a crucial stage in data analysis process where data is transformed into meaningful insights and knowledge. It involves applying statistical and analytical techniques to explore, summarize, and interpret data. Now, during this stage, we determine patterns, relationships, and trends and associations between variables. And of course, it is this stage that will help us to answer the questions we asked in the very first stage. Okay? Now, there are many methods of data analysis. We have descriptive statistics, we have visualization, and inferential statistics, and stuff like that. We have predictive analysis, we have descriptive, we have diagnostics. There are many ways by which you can analyze our data, and the method we choose is going to be the questions we asked earlier is actually going after it says a lot of things about the method of data analysis that we choose. Now, after we might have analyzed our data, the next thing we do is to interpret. Now, as an analyst, the communication stage is very, very important. In fact, it's one of the skills that you have to build. It's one of the skills that you have to build as an analyst. You must know how to communicate effectively whatever result you might have gotten from your analysis. Nobody knows the meaning of mean. Nobody knows the meaning of maybe you have a standard deviation in your data set and in your analysis, and you are not presenting it to your clients. No, you want to know what those things actually mean. You want to know what they mean in real life. You want to be able to tell them that in the next 5 years, this is what will happen in your business. It's not as if you just go there with figures. It is the interpretation and communication skill that you develop that's going to enable you to do what? To be able to discuss the result of your analysis to your clients. Now, I won't be going further about the introduction to data analysis. You can make further research on your own. I'll be going to what we have next, which is data entry with SPSS. Data entry with SPSS. Now, SPSS is statistics. We want to believe we are cool with the installation of SPSS, the statistical package for social science. We're not discussing anything about that. Okay, and I want to believe for those of us hearing and seeing me, and we are with our systems, I want to believe we have opened our SPSS environment. For me here, I have my SPSS version 26, and it's currently opened. Okay. Now, when you open your SPSS, you have a window that displays to you what you want to do, something like that. You can close that window. I already exit that window at this stage. Now, there are two windows that comes up for you in terms of entering your data, and there's an additional window that comes up whenever you complete a task. That window comes out for you to display your results. You are going to see that as time goes on. Now, currently, we are into data entry with SPSS, and for our data entry, we have two windows that helps us to enter our data effectively. The first window is the data view, and the second window is the variable view. If you can see my screen, we are currently on the data view, and if you check the left bottom part of the screen, you are going to see it highlighted in yellow or brown, data view. And when you click on the other one in blue, you have it variable view. Now, the first one, the data view, that's actually the spreadsheet that you enter your data set.
Hello.
It is hello?
Hello.
Yes?
Hello.
Hello, are you with me?
Hello, sir. We speak on. We can.
Hello, please.
Okay, sir.
Speak on, we can hear you.
Hello, sir. We can hear you, sir. Continue. Our tutor,
All
please
right,
continue.
all right, all right. Now, the data view presents data in tabular format with rows representing individual cases. Okay, these rows are representing the cases or the respondents. Each row is representing the cases or the respondents, while the columns represent the variables. The column represents the variable. Now, you can directly enter values into the cells of the data view. If you are very familiar with our Excel spreadsheet, just this is just like the spreadsheet. We can enter values directly into the cells of this very sheet. Now, we can edit existing data. Okay, how? Just by clicking on it, we are going to put in some data now and we are going to see. Now we can be able to view, we can sort, and we can filter our data set from this very window. Now, for us to enter our data, we come to variable view. The first variable, let's assume we want to enter age of respondent. I mean, yes, age. The variable name is age. We put it here in the variable view. I'm typing in age. Now there are some characters that the SPSS will not allow you to input as variable name. It won't allow you to use space. If you put space in between a variable name, it's not going to allow you to do that. Age of. Okay, the space is an illegal character. It will not allow you to use. It will not allow you to use this space. This particular character is also not allowed if you have anything like as such. Is an illegal character. So, okay, it contains basically alphabet and numbers. It allows that. So age.
Hola.
Okay. Hello. Is someone speaking?
Continue, please.
All right. Now, once I put in the first variable, which is age, in the variable view, if I come back to the data view, I have it here. It's already written in that column, age. Now let's assume the first age of the student is 12 years. Okay. The second age is 13, 10, 14, 10, 11, 12, 9, 13, 11, 10, 9, 12, 10, 14, and 10. Let me stop there at number 16. Now, we can see that we are having decimal points, decimal places of two decimal places at the back of the variables. Now, the variable view allows us to be able to set the characteristics of our variable. Okay, if the variable view is a comprehensive overview of the variables in the data set, and what it does is that it allows us to define the properties. We're able to define the properties of each variable in our data set. For example, the age that I just input in my data come back to values as well. As time goes on, we come back to values. Then missing. In case we have, for this variable, in case we have any missing observation, what are we using to denote the missing observation? Okay, at times we might, okay, for this case, it says no missing values, right? And even we have a missing value, we might use maybe 99 to denote the missing value. We are going to put it inside this place and that's why we'll be able to read that anywhere it comes across that particular value is a missing value during the analysis. The columns, this one is just the alignment. And now the measurement type is a very important thing as well for us to take note when describing the properties of our variable. Now the age, it is important that we note that it is not ordinal and it's not nominal. It's a continuous scale of measurement, right? So we are going to choose scale for age. When we are talking of categorical variables, we are going to be using nominal. Okay, and when we are talking of categorical variables that are in ordered pairs of categorical variables. For example, maybe level, 100 level, 200 level, 300 level, 400 level. But we are going to be talking about ordinal. But for now, the scale of measurement for age is a continuous scale, which is the scale. Now, coming back here, we can see that the decimal point and decimal places has been removed. It has been removed. Now, I'm going to be taking manipulation and simulation all together because it's actually very important for us to be able to have that skills if we are going to be doing a lot with SPSS. Now, for example, I want to have another variable. Let's say gender. Sorry. I'm going to my variable view. Start the second variable, which is gender. Right? Now, for this particular variable, I don't want to compute it with my I don't want to type it in. I want us to simulate data for the gender randomly. Okay? I want us to simulate male and female randomly. Right? And that takes us to simulation. I said I will be taking everything in between themselves. Now, I want to have a random set of numbers, random set of genders for the gender. I'll be coming to transform. Okay, compute variables. Are we still seeing my screen?
Yes, we are with you.
All right. At times it is very important for data simulation. At times is important for us during while using SPSS. We might want to test some statistical procedure. Okay, we might need to simulate some random set of data for us to be able to do this. Then you need to have the knowledge of data simulation with SPSS, and that is why the data we are going to be using tonight. We are going to simulate everything. Now, I'm trying to get a gender. I'm typing in the variable name gender, and I'm simulating it randomly. I'm using random numbers to simulate it. And gender is in two categories. It's either you are a male or female. And that's why I'm using Bernoulli. Okay? Now, in this particular dialog box here, you are told that if you want to use Bernoulli, just type random variable rv dot Bernoulli. Then the probability of success that you want could be anything. Let's say 0.35. Close the bracket. Okay. I already have a gender variable for gender 1. Okay. Now, this particular window that popped up is the output window. Anything we compute, any analysis we do, this is the window that we are going to be seeing the results. We can minimize this window. And now we have another variable called gender 1 in the data set. I'm deleting this particular one. Now, I have gender 1 that we simulated randomly. Okay, now gender 1, you can see It is a categorical variable. Why? How did I know? Number one, the measure is already in nominal. Okay. Now, since it's a categorical variable, there's no point putting it in decimal places. Okay. It should be 1 and 0. Right? Now, the 1 can be male and the 0 can be female. Let's now come to our values. Okay, label, gender of students. Now, values now. Here, it's important for us to define what 1 is and what 0 is, so that the software will be able to know during analysis. Okay? Now, for the values, for values of 1, male, add it. And for the values of 0, make it female, add it. Okay. Now, coming back to this place, we can see that we already have gender as male and female. Did we get what I did? I need a response. Hello? Hello? Are we on the same page? I need a response, please.
Continue.
Okay, all right. Thank you very much. Now, yes, we can see how we just easily bring out new variables. All these variables are simulated randomly. Now, we might decide to check okay, we have a total of 9 male and 7 females. Why? Because the probability of simulating them is not equal. I used 0.35. I used 0.5. We are going to be having equal number of male and female. That's just mainly simulation. And of course, we can simulate some other things. It's not just 1 and 0 that we can simulate. We can simulate some data that follows normal distribution. We can simulate some data that follows uniform distributions. We can simulate stuff like that. Of course, Poisson distributions, events that occurs in real time. We can simulate all these things. Let's compute another variable. Let's say we want to compute height, the height of these children, and of course random numbers. And height is following a normal distribution. We are going to be picking random rv.normal. And you can see the format down here. The format here is, you can see the format here. Okay, we are going to be using the format in this place, rv.normal. And now it's asking us for the mean and standard deviation of the variable that we want to compute. Let's assume the mean of the height of those children is 55 centimeters and the standard deviation is let's say 3.5. Okay, I'm renaming this to height. Okay, we have the height of the children computed again, simulated randomly. Now let's assume we want to simulate levels, okay, from 100 level to 400 level. This we are going to be using, I think, normal distribution. Uniform distribution. It has a upper band of 400 to 400 level, 100 to 400 level. That's an upper band of 4 and a lower band of 1. We're going to be using the level and random numbers, of course. I'm looking for uniform. Now, for uniform, it's asking us for the minimum and the maximum values. Okay, the minimum and the maximum values, and that's what we are going to be having here. Rv.uniform, the minimum value 1 and the maximum value 4, or let me say yeah, let's just 1 to 4. Okay, now he's showing it in decimal places. Of course, it shouldn't be in decimal places. It should have, it should be in 0 decimal place, and it shouldn't be a scale because it is a level. It should be what? Should be an, should be ordinal. Okay, and that is why it is very important for us to be able to define the characteristics of our variables. If we are able to define it properly, then we won't have problem with the analysis. Are we on the same page, everybody?
Yes.
All right. Thank you very much. Now, there are some points that we may need to create dummy variables. There are some points that we may need to create dummy variables. Okay, I want to create another age for these children because this age is actually too low for people in university. I think I'm assuming these people are in the university, 100 to 400 level. So I'm creating another age. I'm creating another variable for their, another random number, another random variables for their age. So I'm deleting this particular age. Okay, let me create another age, computing another variable. Of course, the age, let it follow, is following uniform. Let's say the minimum age in that class in university, let's assume it is 16 years old, and the maximum age, let's assume 30 years old or 32. But for this case, let me using 25. Okay, so I'm naming the variable age. And of course, my age is a numeric, and it should be in 0 decimal place, and is a scale. Is a scale. Good. I don't have the age of my students. I have level, height, gender. Now, there are cases that will warrant us to create dummy variables. For example, level. It has 4 categories: 100 level, 200 level, 300 level, 400 level. Now, I might want to create dummy variables, and of course, if you want to create dummy variable for this particular level, because it has 4 categories, we are going to be creating dummy for how many? For 3. And the last one is going to serve as our reference category. Let's assume we are going to be using 100 level as our reference category. We are going to be creating dummy variables for 3 variables. Now, I'm going into data manipulation now. I want to create dummy for level. Now, transform. I'll be recording into different variables. What am I recording? Level. I'm bringing level inside this dialog box. Now, the very first level I want to code is the 100 level. I'm sorry, 200 level. I won't be doing for 100 level because I'll be using them as my reference category. Label. I can still use 200 level as my label. Change. Oh, the letter characters. Let's 200 level. I'm using 2 as 200 level. Change it. Okay. Old and new values. Now, for values, 200 level. If it is 2, give me 1. All other values in that variables, give me 0. Continue. Okay. Are we still with me?
Yes, we are with you.
Yes.
All right.
Yes.
Everything I'm having zero, and it's not supposed to be. I'm supposed to be having one. Anywhere I have zero, I'm supposed to be having one. Anywhere I have zero, and every other ones should be. Let me try recording again. Level. Let me label this. Uh, Let me try to recode the variable. Okay, I'm recording to different variables. Level 200, 200 level. Change it. Old and new values. Okay. Should give me one. Two. Give me one. Hard. All other ones zero. I'm still having the same issue. Probably because I'm using a data that I simulated. When we go into proper analysis tomorrow, we are going to see how to uh, recode, create dummy variables properly. Okay. Now let's look at how we can transform our data set. Okay. For example, we have some data sets that are the values are very large and they are in millions. Of course, if we want to do analysis and we want to perform our descriptive statistics, it is very necessary that we don't change the what I say now. We don't change the nature of the data set before we perform descriptive statistics. We perform descriptive statistics on the raw data set without transforming it. But however, after transformation, we may need to after the descriptive statistics, we may need to transform the data so that we're able to say some meaningful things about the data set, about the result of the analysis. Now, there are at times we may need to take the logarithms of the data. We may need to compute the logarithm of the data. We may need to okay. Now, for us to compute logarithm, like we want to take a log of the entire data set, or maybe we want to difference our data set in series of time series analysis and something like that. We are going to be using instead of going to the random number of a thing. Before we're using random numbers, we are going to be going to the arithmetic in the computing variable windows. We are going to be going to the arithmetic. Now, under the arithmetic, we have the artan, cos, exponential, the log to base 10, the ln, and so on and so forth. Now, I didn't want to compute the natural logarithm, the link to base 10 of any variable. We just pick we pick this. Now, the code is telling us that we write log to base 10 and we send in the particular variable. For example, in this case, I didn't want to take the log of the age of those students. So I'm going to type LG 10 and then the variable that we are computing the log, we send it into the bracket. Of course, we should know that we cannot compute the log of a string variable or categorical variable. It's not possible. All right. Let's give it another name. Log of age. And we have the variable. This is very, very important, especially whenever we are doing some kind of maybe time series analysis and we want to take a difference of our data set. Okay, we may need to take the first difference, second difference, or even to take the log of the data set before we can continue with the analysis. Now, and at times, the variable that you may be working with, they may not be measured in the same scale. For example, some are measured in millions of naira, some are measured in very lower scale. Now, when we take the logarithm of the data set, it will help us to have the same scale for our data set, and we are going to be able to what? To draw meaningful inferences from our analysis. And that our data set there, that there's going to be relationship between one or two data sets, like one or two variables in our data set. For example, if there is coordinarity between two variables, okay, there are some remedial measures for us to take to sort that problem. All right, like dropping of variables, collection of new data set and stuff like that. But if you don't want to do that, we can take the log of the data set. All right, we can take the log of those variables, and doing that is going to help us to be able to alleviate the problem of coordinarity between them. Now, another reason is because the data sets might be measured, they might not be measured under the same scale of measurement. I mean, some might be measured in millions of naira, for example, and you now have another variable that is already converted to something lower. Okay, now when you take the log of those two variables, you are going to be able to make them operate in the same level. Let me say it like that. Do you understand?
Okay, sir.
Do you understand?
Yes, sir. Yes, sir. You can move on, sir. Thank
All
you.
right, all right. Now, tomorrow we are going to be dealing with a real life data set, and we are going to be performing some little analysis on it. Not little, but little as well. Something very basic, but very important. Now, let's look at some basic descriptive statistics without even going to a very far place. Some basic descriptive statistics. Now, I want to do the description of this particular variable. I don't want to go to analyze and start pressing stuff like that and quickly, I want to do some things. Okay, you can just pick the variable that you want to do the descriptive statistics, like I've done now. Right click on anywhere on the variable and click descriptive statistics. Okay, and you're going to have the output. And even I'm describing this descriptive statistics, I have the output already, the mean, median, standard deviation, the range, and stuff like that, just with 2 clicks. Just with 2 clicks, we have done our descriptive statistics. Now, sorting is very, very possible. For example, I want the male, I want the female to come first on this table, and I want the male to, to be at the lower part. I can sort them in ascending order. All right. At times, it is very important for us to do this, so as we are going to be able to view our data set in a very appropriate manner. At times when we are not seeing our data set clearly, we will not be able to know some things that are wrong or some things that should be done when we are dealing with a very large data set. So doing this, we are going to be able to know basically some things that we can sort the level as well. We can sort the levels in ascending order or in descending order. We can see basically that we have just 200 level students among them. Just with sorting, we can be able to describe the data set. All right, it is necessary at times. Which other? Okay. Now, I'm coming to this reading now. I'm coming to this reading. Let us look at some few things on this reading, and we are done for tonight. Now, for this particular button is for us to go to a particular case. Maybe we are dealing with a very large data set, and we are looking for a particular case. A particular case. What do I mean by case? Now, I'm looking for respondent 200 on a very large data set. I don't want to be scrolling. I don't want to be going far before I do this. It's just for me I can just click this particular button. Okay, go to case number 15, and with that click, I'm there. Now, I don't mean it's a variable I'm looking for. In a variable I can be working with hundreds of variables. I need to locate a particular variable. I'll click on the variable tab, and I'll type the variable, probably age. Go there. It goes there for me. That is what this particular button does for us. It's very, very simple. Now, the other one is go to variable, just like what we did before. I don't know why they put it separately, but it's in the same tab. Now, this particular button I just click, it gives us information, basic information about our variables. Okay, for example, the height of students. It tells us that the name is height, the type, the missing values, no missing values, and the scale of measurements. Okay, that is just what this particular guy does for us. And this one is a descriptive statistic, just like what we did before. If you want to go with right clicking and pressing this, we can just click on this particular guy. It will run descriptive statistics for us as fast as possible. Now, this particular guy is for us to search. Okay, looking like a microscope, or what's it called? It's for us to search. Probably we want to look for a particular stuff. Now, I want to look for female, for example. Find. Oh, it's a string. Now, on this particular variable height, I want to look for height number 60. Now, look for it. We have it highlighted already. Now, had it been in all the case of height 60, there was a mistake. What I'm supposed to have there is height 65.5. Instead of you to be looking for means to scroll up and scroll down to replace all these things, I can easily come to find and replace, look for height 60, replace it with height 65.5, and of course replace. Replace all. Does not match any. Okay, 60.00. Let's see if that works. Okay, now it has replaced it with. Now, had it been there was a mistake here on this column, what I'm supposed to have is boy instead of male, and I already have thousands of male. What do I do? Do I discard the data set, or do I start typing to change it one by one? No, you can easily come to this, highlight the variable, come to find, then find and replace. What am I looking for? Under gender, I'm looking for male. What am I replacing it with? With boys. Okay, we can replace. It's saying that it doesn't match. Let's see why it's not matching. Replace with boys. No replacement was made. Let's find first. Let's find male. Find next. Find next. Find next. Find next. Let's use female. Find next. Find next. Find next. Find next. Find next. Okay, now let's replace all the females with ladies. It's not seeing it. I don't know why. But actually, we can see how it works perfectly for height. Let's try it for level and see what happens. Find and replace for level 1. Want to replace it with. We are looking for level 1. Level 1. We are replacing it with level 100. Replace all. You can see how the find and replace button was able to replace this particular button in just a click. I think now this particular button, it will help us to split the data set into two. For example, I want to split according to the gender. Let me use gender of students. Okay, it has helped me to split the data set according to the genders, male and female. And of course, it came out with some descriptive the sort cases and stuff like that. And I think these are the basic manipulation skills and what's it called, and entry skills that we need in SPSS. And of course, we can explore before tomorrow's class. Tomorrow's class is going to be very much expository because we'll be dealing with real analysis. Tonight is just to show us the environment and stuff like that. We are going to go for that tomorrow. And of course, there's nothing impossible. We can import data sets from Excel. We can import from Excel. Importing from Excel, we can either import from as Excel, XLSX file itself, or CSV file, or even text data SAS data or stuff like that. But most of the time, we are going to be importing from either Excel file or CSV file. That is possible. We are going to look at that tomorrow. And of course, we can save our data set. The format of the save of SPS is .sav. Whenever we see .sav file, we should know that it's an SPSS file. And of course, we can save our data set and open it when next we need the data set. And I think for tonight, that's just the basic data entry skills, data manipulation skills, and data simulation skills that we need in SPSS. We can explore more on our own. Thank you very much.